So what is a rational expression, basically? So a rational expression is an expression that contains fractions with variables in the denominator of the fraction. So some examples of rational expressions and non-rational expressions. So a rational expression would be something like 1 over x. So there's a variable in the denominator. Something non-rational would be like x over 2, because the denominator is an actual number, not a variable. So the key is that there's variables in the denominator, and that's what makes it a rational function. We can also have variables in the numerator as well. So you could have something like 2x plus 5 over x squared, and that is also something that's considered a rational expression. As long as the denominator has a variable, then it is rational. So in order to understand and work with rational expressions, especially with our particular textbook, we need to have some understanding of domain. So I'm going to go into domain on various types of expressions before we really go into the simplifying of rational expressions. So the domain of an expression is the set of real numbers for which it is defined. Domain is specific to the inputs, or the x values. So think of it as the inputs, basically what you can plug into an expression. And it's basically, we think of the domain as the values that you're allowed to plug in and you don't come up with any errors or anything. And so determining domain does involve some critical thinking and some memorization. So if you have radicals, which means you have a square root or cube root or something, the domain is all real numbers. So you can put anything in for x where that whatever's inside the square root is greater than or equal to 0 and solved for the variable. This actually is particular to even roots, because we can't have negatives inside an even root. So whatever's inside there has to be greater than or equal to 0. And so we determine where that is and then solve for the variable. And solving for that variable, that is something we actually cover in 1.7. So you guys have not seen that yet. Polynomials, we've talked about polynomials. For polynomials, the domain is all real numbers. So that's when we basically just memorize. Every polynomial, the domain is all real numbers. And then rational expressions, the domain is all real numbers except where the denominator is 0. And that's because you can't divide by 0. If you divide by 0, you get undefined. And so any number, any value for x that makes the denominator 0 gives us undefined, and so we can't plug that number in. And so those are excluded from the domain. And that's the part that we really have to talk about domain because of rational expressions, because we have to take that into account. So I've got 3 examples here, finding the domain of the expression. So the first one, we have 6x squared minus 9. So this is a polynomial. And polynomials, their domain is all real numbers. Except in this case, they tell us x has to be greater than 0. So because they're telling us that, that means our domain is x greater than 0. Because they're specifying that we're not including the negative numbers here. So what that means is we can only plug positive numbers into 6x squared minus 9 for this particular expression they've given us. The second one here is a rational expression where the denominator has a variable. So the domain is everywhere except for where the denominator is 0. So this is a rational expression. And so what you do is you take your denominator, and that cannot equal 0 because then we're dividing by 0. And so you ask yourself, what number will make that 0? So if x is -5, we'd have -5 plus 5, which would be 0. So x cannot equal -5 because that will make that 0, and it's not allowed to be 0. So our domain is basically all numbers except -5. And you can actually, there's a nice little trick. The not equals is just like solving, and we haven't technically learned about solving yet because that's in section 1.2, but it's assumed you've had some experience with that coming in, where if I subtract 5 from both sides, that's how I get x is not equal to -5. The last one here, we've got the square root of 2x minus 5. So this is a radical, and it has an even exponent, which means whatever is inside there needs to be greater than or equal to 0 in order for us to get an answer out. And so you can do this by looking at the graph and looking at what values are allowed or what values you have it graphed over. We solve this just like you would solve for x. So when we're solving, we start by adding 5 to both sides because we want the x by itself. So that gives us 2x is greater than or equal to 5. And then you divide both sides by 2 to get just x. And that gives you x is greater than or equal to 5 halves. So our domain is x greater than or equal to 5 over 2. And if you look at a graph of this, what that means is that you will only have a graph that is for values of x greater than 5 halves. So I'm actually going to bring that up so you can see that. So I'm going to bring up Desmos. And I'm going to put in the square root of 2x minus 5. So x is our horizontal. Now this is, this graphing part is technically something in P.6, but it's assumed you've kind of had some experience with graphing before. So 5 halves is 2.5. So you can see for x values, that's the horizontal, that are equal to 5 halves or greater, we have our graph. But for any values smaller than that, we don't have anything graphed. So the domain is basically where do you have something graphed? And we have, our graph is present at 5 halves and larger. And you can zoom out, we can click and scroll, and it just keeps going on forever. So that's basics for domain, and that's how you can use the graph to kind of reinforce finding the domain and everything.